Thank you so much, and of course, many thanks to all of you guys for joining. As mentioned, today is all about questioning reality. Today I want to perform a reality check. I really want to tackle the question, what's the role of manual testing in DevOps? But before we do that, before we dive into that topic, let me say at least some words about my background to put more drama into the story. So I'm Ingo. I'm working for Tricentis. Tricentis is a software company. We are based in Vienna. And we are the bad guys on the block. We are the tool vendors in the field of software testing. And at Tricentis, guys, it's all about automation. So we provide tools for end-to-end automation. Tricentis Task is the keyword here. We provide tools for cloud-based distributed load testing, Tricentis Flood. We provide Tricentis Q-Test to enable you to orchestrate your test management process, especially in agile development environments. And we just recently released an awesome tool for robotic process automation, which we simply call Tricentis RPA. Now, with all that, guys, and that's the end of my marketing pitch now, I think it becomes obvious that automation sits at the core of our company. And that is what we are trying to do. We were trying to democratize automation. We are trying to bring automation to everyone out there, not just to the technical people, but also to the non-technical people. But at the same time, guys, we are also well aware of the fact that our tools don't do the testing. So we like to view our tools as classes. And just as classes do not see, tools do not test. The classes just help us to see. And so the tools help us to test. So we like to see our tools as something that accelerates, that amplifies, that intensifies, and often, hopefully, also simplifies the testing done by human testers. And in addition to that, testing to us is not so much an act of artifact management. Testing is not so much an act of test case management. Testing is so much more to that. And as already announced today in my pitch, to us, testing is no more about test cases than astronomy is about telescopes. Now, guys, if we would reduce testing to an act of checking, to an act of test case management, where you create, you automate, you execute, and you maintain your test cases, then I think we also would need to accept the fact that when we are testing badly, automation would just help us to test badly at an accelerated rate. Because the tools don't care, guys. They accelerate bad testing in the same way they accelerate the good testing. So what we need to avoid is that we automate chaos. Because if we automate chaos, guys, all we get is faster chaos, right? Now, how does that usually look like? Well, guys, here is a typical software testing timeline based on the few data points I've collected over the past 10 years or so. And this timeline is composed of 4 phases. Now, in the first phase, I hear the people saying, testing? I've never heard of that, right? There is only automation. We automate everything. Now, guys, it then takes quite some time until those people fall down what I like to call the Mount Stupid of software testing. And then they immerse into what I like to call the valley of despair. And in that valley, those people then start saying, okay, there is testing, and testing is probably more than just automation, but we are just not convinced that we really need it. And the last 2 phases often then look like this. So now let's zoom into those last 2 phases to see what's really going on there, guys. And now I need your imagination. Imagine that all these dots here represent all the test cases you have in your regression test portfolio, no matter whether they are automated or manual. And now imagine that all these test cases pass in the last regression test run before you decide to ship your product into production. And then you might conclude, well, that looks good, right? Ship it, ship our software product. And that is what it then most probably will do. But just a second later, you will then see something like this, right? You will see that repetitive test case execution is by far not enough to see that iceberg coming, right? So now the question is, how do we avoid scenarios like that? And in order to tackle that question, I need to explore the field of testing at least a little bit. Guys, I think in the same way you can handle your toilet paper in 2 ways, I think you can handle testing in 2 ways. So to me, just seeing it black and white for that moment, the coin of software testing has 2 sides. And the first side is all about confirmation, and so we call it confirmatory testing. The second side of the testing coin is all about exploration, and so we call it exploratory testing. So let's briefly compare those two testing cultures to make sure that we speak the same language. Now, when it comes to confirmatory testing, you will see that's a very mechanical approach to testing. So, especially when it comes to automation. Because automation is just doing what automation does. It just processes predefined data through your application in a predesigned way of actions, test steps, for example. Now, exploratory testing on the other side of the fence is a very creative approach to testing. So here it is all about learning the product, designing tests, executing them, and interpreting the test results all at the same time. So you do all of these activities almost simultaneously. And in doing so, your next test is always influenced by the results of the last test you did. And that's the reason why we call that approach for testing exploratory testing. Now, this then implies that the purpose of confirmatory testing, for example, repetitive, manual, or automated test case execution, is all about monitoring known risks. So here we just confirm what we already know. We confirm our existing beliefs. Whereas the purpose of exploratory testing is to analyze potential risks. So here we focus on things we don't know. We focus on illusions we are holding true without any empirical evidence. Now, this then implies that any exploratory test you perform has a high information value associated with it. Why? Well, because we learn something new about our application. That's not the case with your manual or automated test cases, for example. Now, the bottom line is, and that's the way I like to see it, that all your confirmatory tests are like change detectors. Now, why is that? Well, imagine you add some new functionality on top of your big fat software product. And that you want to know, well, does this newly introduced functionality have some bad impact on my already existing functionality, right? So what do you do in that case? You run your automated regression in order to detect those bad changes. On the other side of the fence, exploration is all about discovering new territories, questioning the product in different ways. And so the exploratory tests you perform are more like problem detectors. And James Bach once summarized it brilliantly, where he said, when you do exploratory testing, here you focus on the unknown, the invisible, to avoid the unthinkable happening to the anomalous. And I'm just in love with that view on how he sees testing. Now, confirmatory testing is then part of a much larger concept. And that concept is now known as checking. Now, according to Michael Bolton and his fellows, checking is about evaluating a product by applying algorithmic decision rules to specific observations of a product. So nobody gets what that means, right? Now, in simple terms, here you just mechanistically operate your product. You operate your product in an algorithmic way. And this means, in simple terms, here you just try to answer the question, does this assertion pass or fail? And this question always has a binary result. It's either true or false, it's yes or no, or 0 and 1. And this means that the process of answering this question is algorithmic. And this means it can be automated. And guys, guess what that means? It should be automated. Because we don't want human testers doing something a machine can do, right? We want them doing exploratory testing, where you evaluate the product by learning about it through exploration and experimentation. And this usually involves a hell of a lot. Human capabilities, such as learning, questioning, studying, exploration, experimentation, and a hell of a lot critical thinking. And in contrast to checking, exploration is more confronted with a much bigger question. And the question is there a problem here? Now, that's just a subtle wording difference, but this asks for an entirely different testing mindset. And this question usually does not have a binary result. I can often not answer this question as a yes or no. And that is where, the human brain gets into the game. Now, let's briefly sum that up. Guys, when you check your software, then you evaluate your software through following predefined procedures. You follow instructions that are contained in your test cases. And you do that by paying attention to the deviations of the expected results in your test cases. Now, this means that checking is all about creating test cases at the end of the day. And you do that by following specific procedures to examine specific conditions in your requirements. For example, the acceptance criteria in your user stories. Now, when you reduce testing to checking, you make testing become a factory process, where you just put requirements into that factory and you get test cases out. Now, in contrast to that, exploratory testing is all about investigating your product by performing powerful experiments. And those experiments may be driven by a set of your testing heuristics you apply during your exploration. And here you don't just pay attention to the deviations of some artifacts like test cases, here you pay attention to anything that might help you to decide whether there's a problem in the system or not. And this might be a specification, a reference system, or it might be something you guys discussed the last night with your developer friend, right? So that's a test oracle. And this means that when you do exploratory testing, it's all about creating test ideas rather than creating test cases. And you do that by following your clues to examine potential risks. And this is what eventually makes testing become an adaptive investigation rather than a factory process. Now, this then tells at least me that checking, as said, is a mechanical process. Exploration is a creative process. So when we reduce testing to checking, then guys, what you're doing is simple. You turn your testers into checkers. You turn your testers into robots. Whereas when you focus on exploring new territories to gather new information, quality-related information about your software, you turn your testers into powerful investigators. And those two testing cultures are tightly related to each other. There's a constant back and forth when you do testing. Now, here is how I like to see it. Now, I always remind myself that behind every test case I create, there is a test I perform. And behind every test I perform, there's a test idea I've had. And behind every test idea, there's a human tester. Now, this happens when you view testing not just as an execution activity. This happens when you view testing also as a design activity. And I always tell myself, when my automated test cases, for example, suck, guys, it's probably me who sucks, okay? Because there's always the human tester involved here. And this also means that there's a lot of exploration going on even when you do checking. So checking is surrounded by a hell of a lot of exploration. And Michael Bolton brilliantly summarized it by saying, checking is a guest in the house of testing. Exploration is a permanent resident. Now guys, please, please, please don't get me wrong on all this. I'm not saying that we value exploration over checking. That would be way, way too simple. So all I want to say is it's not just about the one or the other. It's about both at the same time. And so we regard something as thoroughly tested in all of our projects when it has been checked by efficient, formal test case automation, for example, and when it has been explored by the richness of intellect of human beings, by you guys. Now that's our agile testing equation. And it just says that testing contains checking in the same way it contains exploring. Now when we check, guys, we can do that in two ways. The machines can perform the checks through automated test case execution, then we call it machine checking. But also the humans can do it through manual test case execution, right? Then we call it human checking. So when I'm talking about the concept of manual testing, I'm essentially talking about two things that make up manual testing. I'm talking about human checking and I'm talking about exploratory testing. Because both require the human being. Both are manual activities you perform. And because of the fact that exploratory testing is such an integral part of the concept of manual testing, I'm firmly convinced that manual testing will never go away in those fast-paced development environments or your DevOps environments. Until, of course, guys, some general purpose artificial intelligence like Skynet comes around and takes over the world, right? But this won't happen in the next few days, and not even AI research honestly knows how to achieve that, how to create artificial general intelligence, to simulate the human thought process that is involved when we test our software, hopefully. Now, the good news here is that exploratory testing, and so testing, is not a talent. So you don't need to be a super smart person and a bright mind, an Einstein-like mind to do that. It's just a set of skills. And these skills is what you can learn. So let me now briefly walk you through at least the fundamental pillars of our approach to exploratory testing, to show you what skills we think are required in order to do that efficiently and also effectively. So let me show you how we translate the approach of exploratory testing into practice. Let me show you our technique. And in really rough terms, our technique is composed of 5 components. Now, the first one is what we call session-based testing, or what is known as session-based testing. And what session-based testing does is fairly simple. It takes exploratory testing, and then it puts exploratory testing into a straitjacket. So it puts all the imagination that comes along with exploration done by human testers into that straitjacket. And by imagination, I just mean the ability to form new test ideas. And now you might say, well, that's a crazily bad idea, right? So why the heck do you do that? Well, the reason why we do that is to make exploratory testing structured, to make it somehow management compatible. Because the challenge is not to do exploratory testing consistently for 1, 2, or 3 teams. The challenge is to do exploratory testing consistently for 30, 40, 50, 60, or even more teams in a truly agile enterprise, guys. That's the single reason why we go for session-based testing. Now, the core object of session-based testing is a session. And according to John Buck, it's just a chartered, reviewable, and uninterrupted unit of testing effort. That is what a session is. And that unit of testing effort usually is time-boxed. And we don't just time-box a session for the sake of time-boxing a session, we do that for a reason. Now, we time-box a session, that means we allocate a fixed time frame to our exploratory testing session. And the reason why we do that is to curb our perfectionist tendencies during testing, to avoid that we dig into the same hole deeper and deeper and deeper and deeper. Because this usually happens when there is no deadline, right? I think we all experience that. Now, the core object of a session is the so-called session charter. And this is nothing more than just a mission statement. A mission statement for all the testers that are part of your exploratory testing session. It might be one, it might be multiple testers, or multiple people. And what we do here we precisely and concisely describe what we are looking for in our session. So here, basically, we define 2 things. We define the scope and the goals of our testing sessions. And that is what I do on a daily basis. Now, how do we define the scope of our testing sessions? Well, we do that by applying a traditional requirements-based testing approach. And to us, a requirement is just a service. It's a service we provide to our end users so that these guys out there can achieve their goals, whatever they are. And you might express those requirements as user stories, epics, as themes, as system use cases, business use cases, stakeholder needs. Take whatever you like, guys. At the end of the day, these will be requirements. These will be services to enable someone else to achieve their goals. And we take those requirements to define the straitjacket of our session. And this is especially helpful to help, especially unskilled testers, to deal with that scope. And when we do that, when we explore that scope, when we're trying to find something new in that scope, we don't just compare the actual product to its product description, specification, for example. We also compare the actual product to its product idea. And we also compare the product idea to the product description. So we don't just verify our software, we also validate our software to make sure that our software also meets the end user's needs. We want to make sure that our software really solves the problems of our stakeholders. And this means we pay a hell of a lot attention to for whom we are building our software. That is an integral part of our testing strategy. Now, when we explore that scope, we apply a bunch of different testing heuristics. And the heuristic, at least in our case, is just a set of questions. It's a guideline system of questions that help us to decide whether there's a problem in our software or not. Or this is something that helps you to solve a problem, or even detect a problem, for example. Now, here is one example. It's mnemonic, the abbreviation of the testing heuristic is RCRCRC by Karen Johnson. And this one, for example, is especially helpful when your software is constantly under change. Another one is one by James Buck. It's called San Francisco Depot. It's abbreviated as SFDPOT. And this one, for example, is helpful when you're completely unfamiliar with your software, when you need to questioning or challenge a completely new software product. So it helps you to gain information about your software. Now that is, in rough terms, how we structure exploratory testing via session-based testing, and requirements testing is what we use in order to find the scope of our sessions. Now, how do we define the goals of our sessions? Well, here we apply an approach which is known as tour-based testing. And a testing tour is not just taking a test case and then calling it a tour, it's the entire metaphor. It's an exploration around the theme. And there are so many schools of tour testing out there, guys, I can't tell you that. And within those schools of tour-based testing, there are so many different testing tours. Now, the one I like most is the one proposed by James Whittaker in 2009. He published a book. It's called Exploratory Software Testing. And this is heavily talking about that concept. And in the book, he talks about several testing tours, like, for example, the supermodel tour, the museum tour, the FedEx tour, the couch potato tour, and the money tour. Now, what these testing tours are doing for you is they allow you to set concrete goals for your session by providing a crystal clear focus. Now, here's an example, the FedEx tour, one of my favorites. You know FedEx, right? It's the label in the package delivery world. Now, what FedEx does, it just takes packages and moves it around from one destination center to another around the globe. That is what FedEx basically does. Now, you basically do the same when you apply the testing tour during your exploratory testing session. Now, what you do is you take a piece of data, like you create a customer in your banking application, and then you try to find every feature that somehow purges, modifies, or deletes that piece of data. And just by doing that, you're trying to make sure if you have a consistent data flow in your application, a crystal clear focus. You just focus on that specific aspect. And then you move on to the next tour, and then you move on to the next tour. That is how we roll it. Now, why do we do all that, guys? I think the main reason why we do all that is to maximize one quantity, right? Quality. Or to be more precise, it's quality at speed. And I think all of you know perfectly what speed means. But what the heck does quality mean? Well, to me, quality, when you look it up in the dictionary, it says it's a measure of excellence of something. I mean, this describes it quite well. But then you can ask, well, who measures this degree of excellence? Well, it's measured by someone. And so Jerry Weinberg once concluded that quality is just some value to some person. And this then means that quality is inherently subjective. Why? Because different stakeholders, the guys for whom you are building your software, will perceive the same product as having different levels of quality. And this says a lot about what a bug is. Michael Bolton said once, a bug is something that bugs somebody. And that somebody is the stakeholder, the guys for whom we are building our products. And then I thought, well, you know, I've worked as a product manager for a couple of years. It's fairly easy for me then to resolve those bugs because I just need to replace the stakeholder, right? So that's one way you could do it, guys. It's a top secret. So what it means is that we as testers must look for different things for different stakeholders, because usually there's not one stakeholder out there. There are multiple stakeholders out there. Essentially what it means is we must try to diversify our testing. And that is what we do with an approach which we call polychrome testing. Now, polychrome just stands for doing an art of work in multiple colors. That is basically what that term means. And that is what we try to do with our approach to testing. Now, how do we do that? Several concepts. One of them is a concept known as the 6 thinking heads. It's part of a much larger concept known as lateral thinking. It's a concept from Edward de Bono. He is a Maltesian thinking guru. And he wrote a great book about the 6 thinking heads. And this concept has nothing to do with testing at all. This concept is being used in general to solve business issues. And we just applied to testing. Now, this concept is composed of 5 components. Those 5 components are those heads, as shown here on the screen. Now, each head, as you can see, has a different color associated with it. And each color stands for a different viewpoint, a different thinking direction. So what we do is, when we run an exploratory testing session, and for example, we invite multiple people from different departments to our testing sessions, then we optionally give them the chance to pick a certain hat, so that they think under a certain thinking direction. So we have some people who really think critically about our software, some people who think more emotional about our software, right? So they just try to express what they love, what they like, what makes them passionate by using our software, and all that feeds in to providing quality-related information about our software. Because the reason why we test our software is to provide that information to someone else. To provide quality-related information, for example, to our product managers, to our product owners or developers. And the reason why we do that is to enable them to make better decisions. That is how I think the purpose of testing. And the last component, I need to come to an end now, is what we call scenario-based testing. And this is just a fancy name of saying, hey, let's just record all the test ideas we have. Let's document them. And here the tools get into the game. They help us to do that in order to make the whole thing reviewable. Now, guys, the main lesson we have learned in all of our projects by applying those techniques is that testing definitely is not so much a thing you do. It's much more a way you think. So to us, testing is a thinking process, right? It is something really happening in our heads and not in our tools. And if we want to change, guys, if we want to change the way we test, we need to change the way we think. Thank you so much.